So here's a brief overview of what we call the for loop. This is a for statement, and what you're looking at here, if you go onto the Arduino website to the reference library, you can click into and read their description of how to use a for loop. In our book, which you should read for homework, pages 45 to 48, it also goes through a description of how to use for loops. So those are your references to use. Here's the format for a for loop. Starts with a variable declaration here. And you'll notice it says optional. What I would like you to do is not to declare a variable and initialize it here. You should do that in the beginning of your program or at the beginning of your function that you're working in. So rather than saying integer x equals 0 and setting up in a variable x and putting a value of 0 in there right here, do that up above. And down here, all you're going to do is put in the letter x. So your statement that you would have in here would say for x semicolon x is less than 100 semicolon x plus plus. And I'm going to explain on the next page what this means. So I've got a flow chart to show you how for loops work and some sample code, but let me just explain the parts of a flow chart. Alright, this is called a looping control structure. In the past, all you've been able to do with loops is to use the crazy loop that they have on the Arduino that runs forever and ever, which I don't like. So here's your introduction to how to actually create a loop. And you can see in our flow chart we have a looping structure here. Anytime we come back up and around, that's a loop. In this loop here, what we're going to do is we're going to take a look at a variable called count. And we're going to ask a question. Is count less than 10 or not? If it is, we'll print out the count variable. And then we're going to do some math to that count variable. Then we'll go back up and check to see if the count variable is less than 10 or not. If it isn't, continue that loop over and over again until whatever this math is doing takes us up to a value of count that's greater than 10. We'll keep on doing that. At some point, though, hopefully, we'll be greater than 10, and we'll move on to whatever other code that happens afterward in our program. And here's an example of the structure that I would use. As I mentioned on the last page, the example they give is they actually declare the variable and initialize it right here in their example. They said that's optional. And I don't want you to do that in here. You're just going to use the variable that you already created above. So somewhere above in my program up here, I've already created a count variable and initialize it to whatever starting value that I like. So let's go take a look at the format here. So here's the format. You write down the word for, you open up some parentheses, and there's three parts that go into there. You have part A with a semicolon, part B with a semicolon, part C with a semicolon, and I will explain what each one of those is. The stuff inside of your parentheses here is what you're going to do every time through the loop. And that could be nothing, which is sort of unusual, or more generally, you do a series of tasks that you wanted to do each time through the loop. Now, when the loop is done, it's going to continue on to whatever is happening in the rest of your code. So what are the parts of the loop structure here, the for loop, A, B, and C? What do we put in there? A, we're going to put in a variable. All right, that's our counting variable. That's counting us through the loop. And of course, you see I use the word count. In computer science, it's very common to use the letters I, J, and K as counting variables for integers. Instead of counting, say for I is less than 10, and I equals I plus 1, or something like that. Part B is the condition you're looking for. Here's part B over here. So the condition I'm looking for to stay in the loop is that count is less than 10. As long as count is less than 10, I'll continue looping through this structure. All right, that's what this portion here goes. All right, the last part of this, as you can see, that's part C, is some math. And they're going to do some math over on the right here, and this is an equal sign, so that's not an equal. We know that's a left arrow. We're going to store count plus 1 in this case into count. So the math I've chosen in this case is just each time I go through this loop, I'm going to add 1 to count. So count will go from whatever my starting value is. I'll go through the loop, and then I'll add 1 to it. Then I'll go through the loop again, another 1 to it. And so I'm going to bump up my count 1 by 1 with this math. There's nothing that says I couldn't use some other math here. I could subtract 1 each time. So every time I go through the loop, my count could be going down 1. I could add 10 at a time. I could make this a linear function. I could say take 2 times count minus 5. I could take count squared minus 3 count plus 5. I can do any math that I would like here and assign that value into count. And that allows me to do all sorts of interesting things. But that's, in the simplest case, I'm just counting up one by one to do something like 10 times or whatever. Every time I come through this loop then, what I'm going to do is I will do this set of commands. I will add 1, and I'll jump up to my loop, and I'll check again, is count less than 10 or not? If count is less than 10, I'll do it again. And then I'll add 1, check again, is count less than 10 or not? And do that over and over again. Now what I've done for you is I've created some sample code which does just what I showed you. In this code, I ask a few questions, and they are listed. Here's question 1, question 2, question 3, and there's a question 4 down below that I don't show here. And you're just going to run the program. And here's the loop I set up. Up above, I declared my variable, and I set it equal to 0. That's my counting variable that I'm using in my loop. And down here's my loop. All right. So I do 4. Here's my loop variable that I'm using. It says to use that as my loop variable. Here's the conditional statement. I'm going to do this loop as long as count is less than 10. And then each time I go through the loop, I'm going to add 1 to the count. All right. And like I said, this math here is a simple just add 1 each time. I can do other more complex math as well. And then each time through, here's what I want to do. And I could, in this case, I have 1, 2, 3, actually 4 lines of code in this. I could have 500 lines of code that I do each time for all I care. All right, but this is a simple little example. So I'm going to get a nice simple printout that goes on 10 times apparently. So you'll see what happens. I also have a second loop down here. So I use the same counting variable. I set it to 1024. And so I'm going to count through a loop, and I'm starting at 1024. So that seems like I'm going to have a very long loop here. But we'll see what happens. You're going to run this. You'll notice here I've changed my condition to look for count is greater than 0 rather than up above in loop number 1. I'd count is less than 10. And the math I'm doing each time through, rather than adding 1, I'm taking my count value each time and dividing by 2. And so this is going to run a little bit differently, and you're going to take a look at the code and run it and see what happens and see if it matches up with what your expectations are here. So here's the homework. You're going to read the book, pages 45 to 48. You're going to take some notes on that. Jump onto the Arduino reference library. You can read that a little bit and see if there's any more information there that you can pick up. Then run my sample program. Once again, hook up the LED, download and run it, and you're going to turn on your serial monitor, and you're going to copy down exactly what's printed out, and then you can read in the comments that I put in there the 4 questions and answer those 4 questions. Then I want you to take that same code and you can modify it. I want you to keep my 2 loops in there, and then I want you to just cut and paste one of my loops down below and add 5 more loops of your own down below. And all you have to do is tweak them a little bit to make them do the following here. And there's more than one way to do this, but pick whatever way you like. But you're going to use a for loop to do each one of these. So I want you to count from 2 to 10, and you're going to move counting upward by factors of 2. Then I want you to count from 20 up to 200 by factors of 20. And I want you to count from 200 to 100 by factors of 10. And I want you to count from 200 to 500 by factors of 50. In each case, you can print those out using the same print commands that I use. So once again, easiest way to do these is to cut and paste one of my sample loops and just tweak it in each case of these. Just cut and paste it over and over again. And finally, the last one is interesting. I want you to use a for loop, set up a for loop to count from 1 to 1,000,000. Inside the loop, don't do anything. You can just leave it blank. Don't put any lines of code in there. Just before you go into the loop, I want you to print out the time using the millis command. So print line millis. And then do the loop, count to 1,000,000, and then jump out of the loop. And I want you to print the time just out of the loop. And the reason I'm doing this is I want you to see how fast this microprocessor actually runs. So you'll actually count to 1,000,000, and you can look at the time before, time after, subtract the 2, and it'll actually tell you how long it took you to count to 1,000,000.